Hello, this is Team G3R with presenting the Catcher Automation Package Transfer System. The team is made up of Jacqueline Gutierrez, Adrian Rodriguez, Sterling Reynolds, and Marcus Rodriguez. The team is sponsored by HEB through the HEB Senior Technology Leader, Todd Polson. Our mentor is Dr. Yifang Jin for Electrical and Computer Engineering Professor. So for the presentation, we will have a team introduction, purpose and objectives, key design specifications, final design, robot speed update, fabrication, testing and results, project management, and the conclusion. So for the purpose of this project is that currently on the production lines, there are 1 to 2 HEB partners that operate at the end of the line to inspect the jalapeno popper package and to check for any missing labels or tears and to place them in the tote basket. Over time, this creates ergonomic safety concerns in the shoulders and the hands that causes the HEB partners to have to leave or be transferred somewhere else. So HEB has asked us to use a robotic arm that they have purchased and to create an end effector that will pick up the jalapeno popper packages and place them into the tote basket, along with a visual system that will inspect the packages and to see if there are any tears or misaligned sticker placements. So with that, the robot has a 15-pound lifting limit. So we have to keep the end effector light, a visual inspection system has to be created, and then we have to keep integrity of the plastic wrap during transfer. So for the performance, we have to inspect the tray for missing labels, tears, or wrapping issues, place the pre-wrapped packages into a tote in a shingled fashion, and operate with little to no human interaction. This is the current final design of the end effector. We have a 4-piece sectional frame, a pneumatic actuator, 4 bar links, 2 grippers, a right and left gripper frames, and then an action bar and sliders in order to use whenever the pneumatic actuator is in operation. Here we have an animation of the end effector in operation. Here you would see the up and down movement placed by the pneumatic actuator on the action bar that would lengthen or contract the end effector frames in order to open and close the device and to grab the packages. For the visual system, we are using a standard Sony camera that is going to give real-time video stream that would then take that image, put it through an object detection code to determine where the jalapeno popper package is. That code would then relate it into the RoboDK software or the Nuke software that has been used in order to give the robot an idea of where the package is. From there, it is then calibrated and calculated of where the package is, and the robot will then move in order to intercept the package and place it into a tote basket. Here you can see a simulation of the design in motion using a design conveyor on the right side and placing it into where the tote basket would normally be. We will now go into a robotic speed update of us finding the upper limit of what the robot can handle and if we will be able to match or exceed current operation standards. Here displayed on the robotic arm is an end effector from another team that is working in conjunction with us. The speed that is made is from about 60% of the actual operation conditions that we can do. So this is more than enough to match current operation standards and to exceed further down the line what current operation has. Here we have a test of the end effector in operation using a G3R's design to pick up a jalapeno popper and to place it into a tote basket marked for nominal displacement, meaning that the package is safe and that it was ready to be marked and placed for shipping. After the completion, the robot resets to its designated position and then starts moving into the next spot where it can pick up the next package. In this instance, it is detected that it is nominal and that there is fine, so it's moving the package back into the next coat basket in order to place it in the same one. For the creation of the end effector, the team used a 3D printer using ABS software or using ABS plastic that would reduce the cost of the overall price of the end effector. Here you can see the printer printing out one of the frames along with the other frame over here. You can also see the housing unit that is being placed in order to get rid of the airflow that could cause problems with warping. Here are some of the fabricated parts from the 3D printer. We have the bar links, the end effector frame, the grippers, the gripper sliders, and the end effector mounting frame. And then here you see the aluminum bar that we use as the action bar. Here you can see drilling for the pneumatic actuator and then drilling into the frame also for the pneumatic actuator in order for it to fit through. So for the total cost of the project, we had the ABS filament at $200 or $220, the RoboDK license at $145, a 3D printer at $224, pneumatic actuators at $41, airline tubes at $19, and tube fittings for $40.52 for a total amount of $689.52. This is drastically reduced from using a aluminum manufacturer in order to make a robot or to make the end effector and to fabricate this design, which leads us into savings. So the visual system savings has huge benefits. The current robotic vision system can begin at $2,000 for a camera and then increase in price by $10,000 to $40,000 when the kinematic system is applied. With the system created through open source coding software, G3R has saved HEB thousands of dollars. An HEB partner can make anywhere between $50 to $25 at the facility. That's anywhere between $30,000 to $50,000 a year for an 8-hour shift. The meat plant operates from 6 a.m. to 12 a.m. with 2 8-hour shifts on the jalapeno popper line. At the cost of $20,000 to $30,000 for a robot, the implementation of this new method can save over $100,000 per operating line. So with that, when created through 3D printing, the cost of material is cheaper than purchasing aluminum and manufacturing the end effector. The robotic system will lengthen the time an HEB partner can work and protect them from ergonomic problems. The visual system created by G3R has saved HEB on operation costs. And lastly, implementing a Fanuc robot or robots on different operating lines can vastly increase the productivity of the jalapeno popper lines and the whole facility as a whole. Thank you for your time.